Hello dear students, I am Samir Velankar and in this video we will see what are the characteristics of algorithm. I should say what are the characteristics of efficient algorithm. From the earlier video we have already noticed what is the difference between algorithm and program, who writes the algorithm, who writes the program. And what do you mean by time complexity and space complexity of an algorithm? Although we don't know how to find time and space, that will be learned in the later videos. Here we go for learning characteristics of the algorithm. Now, the first characteristics is every algorithm must have some well-defined input and output. Although not necessary, some of the algorithms may not have any input. Some of the algorithms may not have an output, but most of the algorithms must have some input and some output. As a very simple example, suppose we want to write a machine learning algorithm which will tell who will be the winner of the FIFA World Cup, whichever FIFA World Cup is coming up. Then the input to that algorithm will be all the FIFA matches which have been held maybe since 1972. So it will be huge input, isn't it? Who played against whom, what was the data, who won, what was the venue at which the match was played. Imagine we give all this input to our algorithm, and the output will be who will win the FIFA World Cup this year. Great, isn't it? If we are able to write such a machine learning algorithm, it will be nothing like it, isn't it? But you can imagine the amount of input that you will have to give, because studying the input over the past so many years and trends of the teams, we will be able to predict who will be the output, who will be the winner, what will be the output, we will be able to predict. So normally an algorithm has input and output, must have rather. Then every statement of the algorithm must be clear and understood by the reader. Basically, we write algorithms so that the implementer or the programmer knows what is to be done. Then it is decision made by the programmer how to implement it, isn't it? Then it should be very clear that what a particular step or set of steps in the algorithms is doing, and it should be understood clearly. By understood I mean it should be known by the implementer that what is to be done. So that's called as definiteness, isn't it? We should know definitely what has to be done due to a particular statement or for a particular statement. The next characteristic is algorithm must have finite number of statements. Generally, at lower semesters in engineering, students write algorithm starting with step 1, say start. Then step 2, say what is the input of that particular algorithm. Step 3, process, and so on. And last step is end or stop. So, but these number of steps, these steps must be finite. What do you say? You can't say that I have written an algorithm which has infinite steps. Come on, then the reader won't know that when the process stops. You might think that this point was so obvious. Why is teacher discussing it? In the first place, obviously the number of steps have to be finite. But you know what? Many times the number of steps you will see in the algorithm are finite. Okay, 1, 2, 3, 4, 5. Let's say first step is start and last step is stop, fifth step. So you'll say, okay, this algorithm has 5 steps. But it may be that somewhere inside the algorithm, somewhere there is a loop, some sort of loop, maybe while loop. Some loop is there. And when you analyze this loop, you see that this loop is a forever loop, that it is badly designed by whoever has developed this algorithm. That condition written in the while loop and the instructions written in the while loop are such that this while loop will never end. So you tell me then how many times will this 3 and 4 execute? These statements will execute infinitely. It means the algorithm has infinite steps. This should not happen. This should not happen. That means the algorithm actually should end. That's the point. Algorithm should finish in finite number of steps. It should not happen that algorithm should go in a forever loop or maybe in forever recursion if we are designing a recursive algorithm. Okay. The next step about the next statement or the point about the algorithm that whatever we write in our algorithm, whatever statements we write, should be relevant to the problem. We should not write some statements which are not at all relevant or not at all related to the problem that we are solving. In fact, if we do that, then the poor programmer would simply implement those steps, and those implementation of the steps were not needed because those steps are hardly solving any part of the problem that we are targeting. So that's what we call it by effectiveness, isn't it? Every statement should be effective, meaning that every statement should effectively solve, be in the direction of solving the problem. It should not deviate from the problem. So these are some of the four very important properties of the algorithm. Now, as in the earlier video, I said that algorithm is strictly written in some natural language, isn't it? Like English. We write an algorithm usually in English, which can be understood, which can be read by any person who is not even a programmer. So domain experts write these algorithms, and domain experts are normally not programmers. Domain expert may be some experts in their own field who want a problem to be solved, so they will just put up the problem neatly in their own words, isn't it? So the big point is that when you write an algorithm, there is no grammar or syntax for the algorithm. Like if I ask you, how do you write a C program? You will say, I start C program with hash include stdio.h, next I write int main, next I write brace open, isn't it? So there is some strict syntax, some strict grammar to write a C program. This is true for any language, may it be C++ or let us say it is Java. Any language program has strict grammar which should be followed. But while writing an algorithm, there is no strict syntax. Every algorithm writer may follow his or her own way of writing the algorithm. Now, many students, at this particular stage, normally this subject is in third or fourth semester of engineering. Many students complain that, sir, I understand how to write a program, how to write a C program. But when somebody asks me to write an algorithm for that same program, I get confused how to write the algorithm. Now, trust me, this question, should be tackled in this fashion, that you know how to write a program, definitely you know how to write a C program, then there is nothing challenging to write the algorithm. Just describe that program in English, in your own words, as you do, as you can do. More and more you describe concisely, actually, properly you describe the program in your own words, stepwise, that becomes an algorithm. I mean, nobody is going to question you all that I write algorithm in this way. Why have you written the algorithm in your own way? Come on, it's an algorithm, and everybody has liberty of writing the algorithm is in his or her own way. By the way, if you have read some very good books of algorithms, now my personal favorite in the subject of algorithm is a book written by Horowitz and Sahani. Horowitz and Sartaj Sahani. Now, this is a piece of art. This is definitely a very good book, Horowitz and Sahani, and the second book is Corman. This is a Bible of algorithms. Now, if you go to the preface of these books, and what these authors say is that they have a separate page where they say, "Hello, reader, I am going to write algorithm in this fashion. These are the styles in which I will start the algorithm. This is the style in which I will end the algorithm. This is the style in which I will pass the parameters to my algorithm. Or this is the style in which I am going to write input and output, maybe printf scanf. So instead of printf scanf, I am going to write display and accept." So this preface, of all these book writers is so important, and that itself tells us that there is no strict way of writing an algorithm. Everybody creates his or her own way of writing the algorithm and convinces the reader that before you read the algorithm, please try to understand the style in which I am writing the algorithm. I hope you are understanding, and how easy it is going to become to read the algorithm. In fact, I always like reading algorithms rather than reading programs. I hope you will share the same experience as mine in the coming videos. Thank you very much.